Hi, and welcome to this very short and concise lesson. Today we revise electropotential and electrochemical cell. I know this is a topic that requires a lot of application, but you will see that there are some key essential concepts that you really need to know and be confident with, and then you can apply it to exam questions. So in this first part of tutorial, we will do a brief explanation of the very key concept. So don't worry too much about taking notes. If you're part of my A-level chemistry crash course, you do have all of these notes, all of the revision cards, everything that you need to revise. And if you're not, well, you have this recording available, so make sure that you stop, take the notes, and if you don't understand any concept, you can write it in the comments, okay? So let's get started with the essential concepts. So in this first explanation, I'm going to assume that you are confident with the redox basics of AS chemistry, okay? If you're not, click in the link up here so that you can access the very key concepts, or you can download the revision cards to have the very notes handed to you. Because here you must be extremely confident in the meaning of redox. What is oxidation? What is reduction, okay? What is, electrons, the transfer of electrons, the electrons on the right, on the left-hand side, okay? Very important. Because we will expand this concept in this topic, which is the electropotential, by understanding the value of what is called the reduction potential. So the reduction potential is, I'm just going to put the highlighter so you see exactly what I'm looking at the spotlight. Okay, very good. We're looking right here. So the reduction potential, remember that it's how likely is a substance to be reduced. Now, different ways to know it. You can memorize it. So the more positive is the strongest oxidizing agent, the more negative, the stronger reducing agent. But for me, this is really not the best way to learn it. Because remember, during the exams, you're going to have this little anxiety. You have chances of a blackout, which means that you feel like you never studied this, you forgot it completely. So we want to prevent this by using logic. So I want you to think about like things that you can always work out as, for example, you're reading an exam question, reduction potential. Okay, think about what it means. What is potential? Yeah, potential, it's kind of what drives the electricity. So it's a measure of electricity. Okay, physics people, please don't, I'm not doing any specific physics. It's just some tricks for our mind to understand, to remember the topic. So reduction potential, it could, like, I like to remember it as the more positive it is, yet the more electricity it gets. What is electricity? More electrons. So the more electrons it gets, the more likely it is to gain electrons. Okay. In fact, I mean, if you have an electrochemical series, and this can be very helpful if you have an exam question with a whole electrochemical series, notice the first is fluorine, the last is magnesium, right? I mean, fluorine is, we know that it reacts by gaining electrons. Magnesium, it's a metal, it reacts by losing electrons. Okay, so what do you think is more likely to happen for each of it? Okay, you can also think it like this. So maybe if you are stuck, just look at the periodic table and think, okay, wait, so like, what do I know about these elements? Okay. If we discuss transition metals, well, we can't really do this, this, but it's just so that you understand the meaning of the numbers in case you don't remember it. Okay. So I really like it to remember it this way. The more positive, yeah, the electropotential, the more likely is it to be reduced, okay? More likely to gain electron, okay? This means, and we needed to learn to describe this in terms of equilibrium. This means that the equilibrium will lie on the left-hand side. Okay, this is important because when you have open questions and you have to describe like a reaction occurring, sometimes you need to answer it in terms of equilibrium. And if anyway it's more likely to reduce, is a better oxidizing agent. Okay, remember, it's always the opposite. If something is reduced, it's going to act as an oxidizing agent. So the opposite is true for the negative. The negative potential, reduction potential, means that is, negative. I think it as the electrons are going away. Yeah? And this means that it would be a better oxidizing agent. Okay, and is more likely to, strongest reducing agent is more likely to be oxidized, to lose electrons. Equilibrium, therefore, will lie on the right-hand side. Okay? because this is more likely, for example, for magnesium, it's more likely to, to be present on the, as the, like magnesium rather than, gaining the electrons. Hope that makes sense. So another thing that you need to be confident is not just like understanding the meanings of this, but it's also understand how these reacted together and how to write the conventional representation of a cell. Now, remember that a cell, it's like if you think about what it is, we have those it's basically our true redox. It's a redox reaction that generate electricity spontaneously. Okay, this is like what an electrochemical cell is. So we must have two things reacting together. Now, let's say we compare lead and aluminum. Okay, I've rewrote here the half equations. So the first step, if you have these two, you need to think about what is reduced and what is oxidized. Okay, and that's where you look at the values. Remember, it's not necessarily that you have a positive and negative value. You may have two negative values, and therefore you just need to compare the size. So look at this. This is minus 0.13, and this is minus 1.66. So think about which one is more likely to be reduced and oxidized. Well, the more positive is reduced. If the more oxidized is the oxidizing agent. Why? Remember, more positive means the gaining electrons. So the most likely to gain electron is the one is the least. Let's say least negative if it's not positive, which means that the other one is oxidized. You don't even need to do all of this discussion. Okay, so this means that the reaction that is oxidized, it reacts with the first half equation in the opposite direction. So we kind of have to switch it around. Remember, they're reversible, so we can look at forward and backward. But I think it's handy to write it this way. Okay, because now we have these two half equations. We know that this lead plus is reduced to form the solid, while the aluminum is going to be oxidized, okay, from the solid to the aqueous solution. So when we write the conventional representation of a cell, remember that the line in between means it's in contact with, the sulfate is these two lines, and this is also in contact with something. So the two solutions on either side. And then again in contact with. So now the sulfates separate these two cells. Now, the order is the same as the flow of electrons. Very important. And that's why I think it's handy to write them in this way. So you know what to put first and what to put after. So let's look at these solutions. So as we said, the sulfate must be in contact with the solution. So what two solutions do we have from the previous half equation? The aluminium 3 plus solution and the lead plus solution. Okay, but which direction do I put them? Remember, is the direction of the flow of electrons. So we start with the solid aluminium because these lose electrons, and then the lead 2 plus gains electrons from left to right. Okay, so that's how we can work it out. The solutions are in contact with the sulfate, but remember to place it in the order of electrons. So that's why it's useful to put the two half equations in the correct order. So one as a reduction and one as an oxidation. So after you've understood the direction of the flow of electrons, you needed to calculate the electropotential. This is like the most common exam question that you can have, for this topic. Now, I don't like the equation left or right. I don't, because, okay, like you need to do, like you can work out easily this, what's it on the left and what's it on the right of the cell when you do this analysis of what is reduced, what is oxidized, swap with the equation, okay? But for me, it's like not that straightforward. So unless I have to write the full conventional representation of a cell, I wouldn't really think about left and right, okay? That's why I like to think it in a way that for me is like, blackout proof. So we need to swap the equation that it's oxidized, and this is the one that you change the sign of. In fact, notice that this in the electrode, to find the electropotential of the whole cell, the one that is swapped is the one that is oxidized. Why? Because that's the equation that you swap. So I think it's really nice to find it in this way, the electropotential of the cell is whatever is reduced minus whatever is oxidized. So the equation is swapped. That's why the value that we will find in the case of this specific example is plus 1.53. So we revisited how to remember the meaning of this reduction potential. And this is useful in order to calculate the electrode potential of a cell, because you need to know what is reduced and what is oxidized. But it can be useful also if you have to work out the overall equation, because you need to put these two half equations together. And then we've seen how to write the conventional representation of a cell, which is also useful, to do this whole analysis of the flow of electron, the direction, what is reduced and what is oxidized. But then to find the electric potential, you don't even need to write down the equations. If you have the values in the table, you can just do it by knowing that you do what is the electric potential of what is reduced minus what is oxidized. Okay, because there is one equation that you need to solve, and you know that you're all given them in terms of electric potential. So this ends the first part of the explanation, and now we're going to have a look at the fuel cells in this next video.